This is the Permutations and Combinations worksheet. Number 1 says, how many ways can you arrange the letters of the word ant, A-N-T? Let's do this a really easy way, and then I'll show you a better way that'll kind of work better on harder problems. This is a pretty easy problem, but so let's just think about it. We have the letters A, N, and T. So there's one arrangement. So the question is, how many different arrangements are there? So we could think about this kind of logically. We could do A, T, N, right? And I kind of like to think about it in chunks. So this should be all the different combinations or different, arrangements that work with the first letter being A, which I think is true. Let's think about the arrangements where the first letter is T, maybe. So there's T in A. There's T-A-N, tan. Are there any more that start with T? I don't think so. So what about ones that start with N? So we have N, T-A, and we have nat, N-A-T. Okay. Are there any more? I believe that is it. So how many do we have? 1, 2, 3, 4, 5, 6. Okay, so that's great. This is a fine way of doing the problem as long as the word is really short. But if you peek at number 2, it's going to be a much longer word. So we need a more sophisticated way of solving these problems. This is not bad, but I'm going to show you a better way that's going to work on more problems. So what I want you to do is draw, and let's remember our answer. So let's remember our answer is 6, and we'll come back and make sure we get the same answer with our fancier method here. So for our fancy method, we're going to draw a blank for each of the possible the spaces, essentially. For each letter, we're going to draw a blank. So 1 blank, 2 blanks, 3 blanks. Okay, this represents 1 blank for each letter. And now for each blank, I'm going to fill in the number of options we have when we fill in that blank. So in my first blank, I could put A in it, I could put N, or I could put T. So how many total options are there? There's 3. Okay, so there's 3 options for blank 1. What about blank 2? Well, we got to remember we already picked an option. So maybe, for example, we already chose A as the first blank. So if I already picked A, how many options are left for my second blank? So think about it. The answer should be just 2. There are 2 options left for my second blank. So this is 2. Okay. All right, and now for our third blank, how many options are left? We've already chosen 2 letters. For example, maybe we chose A and N. So how many letters are left? Just 1. Okay, so that's not too bad. And the last step is actually really easy. All we're going to do is multiply all of our numbers together. So 3 times 2 times 1 equals 6. Okay, so that's great. And if we look at our other method, these match. So that's fantastic. We got 6 both times. And that is the right answer. I'll go ahead and throw it on the worksheet here. Now, what I want you to think about, though, or at least be aware of here, is there's a shortcut on the calculator. And that shortcut's going to come in handy, like, I don't know, this is easy, but what if you had like 10 times 9 times 8 times 7 times 6 times 5 times something like that was a lot longer, which we'll have something like that later. If you do, I don't want you to waste your time typing in all that to the calculator. So the shortcut here is that instead of putting 3 times 2 times 1 in the calculator like this, instead of doing 3 times 2 times 1 like that, what I can do is I can type 3, and I can go to probability here, PRB, and see the exclamation point. So exclamation point in math means something totally different than what it means in English. So in mathematics, what the exclamation point means, it means take whatever number we have in front of our exclamation point, like the 3, and we're going to multiply it by a number 1 less than it, and then by a number 1 less than it, until we get all the way down to 1. So 3 factorial, and the name for it, I kind of went ahead of myself here. The name for this is called factorial. This is the way we say this is 3 factorial. Another example would be 4 factorial. It's going to be 4 times 3 times 2 times 1. And we stop when we get to 1. Okay, so anyway, let me just show you that shortcut in action here. So I'll type 3 in my calculator. I'll hit PRB for probability. I'll go down to the exclamation point and I'll hit enter. 3 exclamation point or 3 factorial is 6. Okay, so you have the method and you have the shortcut. Now you're prepared to do some tougher problems. So number 2 says, how many ways can you arrange the letters of the word Chris? So Chris has 5 letters in it. So let's think about this. So how many slots are we going to have? We're going to have 1, 2, 3, 4, 5. And our first slot, how many options do we have? We have 5 letters to pick from. After that, how many options are left? 4. After that, how many? 3. After that, how many? 2. After that, how many? 1. So now our only job is to do 5 times 4 times 3 times 2 times 1. And again, I'm going to use my shortcut. I'll type 5, PRB for probability, go to my exclamation point, press enter. That'll compute 5 factorial, which we know is just 5 times 4 times 3 times 2 times 1, and it gives me 120. So 120. So that is the answer to number 2, 120. And that matches my key. That's always a good sign. Okay, number 3 says, how many ways can you choose 3 people from a group of 15? So this is actually the next level problem. So in all the problems we've done before, the way we talk about them is we say that order matters. Order matters. So like in the Chris and the ant problem, the order of the letters really mattered. And I guess what I really mean by that is that when we counted how many options there were, T and A was a different option than T, A, N, right? So the order matters. We're counting different orders as different options. This problem is a lot different because in this case, we're just picking 2 people from a group of 15. It doesn't matter that the 2 are any different at all. We're just picking 2 people. And hopefully by comparing 3 and 4, I'll give you a really clear idea of the difference between what's called a permutation and what's called a combination. This is a tough concept. So in a combination, which is what number 3 is, I know it's a combination because I'm just picking 2 people and it doesn't really matter. They don't have specific roles or jobs. It doesn't matter. We don't need to be able to differentiate the 2 at all. And on your formula sheet, I have some notes here. It says combinations order does not matter. Permutation order does matter. So I'll show you that when we do number 4 here. That'll be a permutation. And it's really similar to 3. I did that on purpose. But anyway, so combination order does not matter. Whenever you're just picking a certain number of things from a larger set, that's going to be a combination. So the way we do that, and this is on your formula sheet too, is in the calculator we're going to do 15, and we're going to do a combination. Okay, 15 combination 2, and the way we do that is we type 15, we go to probability. And in the calculator, it's going to show up as NCR. So that's number 2 on my probability list. And now I put in the second number, which is how many we're choosing from the group, which is 2. And I get 105, which is the right answer. I think my key is wrong, and I need to fix that. There's 100. Ooh, that's what it is. I'm sorry. I picked the wrong number. So this should be 3. It says how many ways can you choose 3 people. I made a mistake, so it should be 15 probability, go to NCR 3, and I get 455, and that matches my key. That's great. Okay, so this is 455 different ways to pick 2 people out of a group of 15. Now, or 3 people, I'm sorry, I keep on thinking it's 2. I think the formula sheet says 2. Now, let's compare this to problem 4, which says how many ways can you choose a president and vice president and a treasurer from a group of 15? So notice this is a very similar problem, but in 3 we're just picking 3 random people. We don't care that each of them has a role, or it doesn't matter, right? Whereas problem 4, each person has a specific role. So what that means is there's going to be more possibilities we can pick, essentially. And for this problem, I'll show you 2 ways to do it. Way 1 is just really similar to how we started. So for method 1, we'll draw a blank for each of our 3 people we're going to pick. And for our first person, how many different people could we possibly choose to be the president? So we know that there's 15 people total. So it's just 15. There are 15 options. 15 different people could be the president. So now you've picked the president. So how many options are there now for the vice president? Well, we already picked the president, so there's only 14 people left. So it has to be 14. Okay. And now there's 1 spot left for the treasurer. And we've already picked the president. We've already picked the vice president. So how many people are left in our population? There's only 13 left. So it's this. Okay. So let's do the math here now. 15 times 14 times 13 is 2,730, so a big number. Notice it's a lot bigger than number 3, even though the problems are really similar. And this is also called a permutation. This is a permutation. Number 3 was a combination, permutation. And our calculator has a shortcut for this too. And it is very close to NCR we used before. But here I'll type in 15, probability. And now I'll go to NPR. The P is for permutation. I'll press enter. And now I'll type 3 because we're choosing 3 out of the 15. And I get the same number. I get 2730. So that is the answer. And there's 2 ways to do it. I'm fine with both. This one's a little more intuitive. So 2730. Okay, so number 5 says, how many different cash 3 lottery numbers are there? Each number has 3 digits and repeats are allowed. For example, 335, 146. So when I say repeats are allowed, what I mean is, we could have numbers like 333. We could repeat our number and that's still a valid cash 3 number. Okay, so let's do our old approach here. We're gonna draw a blank, 1 blank for each option. There's 3 numbers, so I'll draw 3 blanks. And how many different options are there for the first blank? So the options here are the digits 0 through 9. So how many digits are there 0 through 9? There's 1, 2, 3. If I list them all out here, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 options, right, for our first digit. For our second digit, how many options are there now? Are there any less? There's not, because it's the same story. It could be any digit 0 through 9, so it must be 10 again. Okay, what about our third digit? Any different? No, it's the same story. So this is the number of possibilities. That's 10 times 10 times 10, which is 1,000. So there's 1,000 different cash 3 numbers you could pick from. Okay, number 6 says, how many ways can 5 different textbooks be arranged on a shelf? So we'll do all trusty drawing the blanks kind of strategy here. So there's 5 different books, and there must be 5 different spaces for books because we're going to arrange them on a shelf. So let's say these are the 5 different spaces where the books can go. And how many options are there for the first location? How many different books could we put here? So when we first start out, there are 5 total books, so we have 5 options. Okay, so I've placed 1 book. How many books can I place now in the second slot? There's 4 different options, and then there's 3, and then 2, and then 1. So this is really, you could multiply this out if you wanted to, or you can do our shortcut here and do 5 factorial, 5 exclamation point. So to do that, we type 5, probability, number 3, there we go. So that is 120 different ways to arrange those 5 books. Okay, I'm gonna put that on here, 120. Okay, the next problem says, this is a real one from the graduation test. Fulton County cannot use Social Security numbers for its student ID numbers anymore. Instead, each student is going to be given a 6-digit code. The code has 3 random letters, A through Z, followed by 3 random 1-digit numbers, 0 through 9. How many different codes are possible given these constraints? So let's think of an example code here. An example code might be ABC123. So here's an example code. And they want to know how many codes are there. So just like before, we'll make a space. We'll make a space for each part of the code. There's 6 things here, 6 elements, so we'll make 6 spaces. Now for my first letter here, how many choices do I have? Well, I have the letters A through Z. So how many letters is that? You could count if you want. Hopefully you know that there's 26 letters in the alphabet. So there's 26 options. What about my second slot? How many options are there? Well, it's the same story. There are 26 options because I could have 26 different letters. Same thing for the third slot. Okay, fourth slot. Now we're on to numbers 0 through 9. How many options are there? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 different options. 10. Same thing here. Same thing here. Okay, so now it's calculator time. We're going to multiply everything together. So I'll do 26 times 26 times 26 times 10 times 10 times 10, which is a big number, 1576000. And I'll look if I see that down here, and I do 17 million. So that is answer choice A. So that is A. Number 8 says there are only 10 students who applied for internships. Oh, excuse me, there are 10 students who applied for internships. Only 3 positions are available. How many different groups of 3 can be selected from the 10 students? So this is another tough problem. You have to think, do I use a permutation like number 4, or do I use a combination like number 3? Now, the question you should ask yourself is, are these students, do they have specific roles? You know, is one like the president and one is the vice president? Do they have specific roles? And if we look, it just says we're picking 3 positions, and it sounds like all positions are the same. So that means it's going to be like number 3, which is a combination problem, combination. So we're going to use our combination button on our calculator, and we're going to do 10 NCR, which is how we do in combination on our calculator, 3. So I'll type that in now. I'll do 10 probability NCR 3, and I get 120, which is answer choice B. Number 9 says Kenneth has 20 action figures. He would like to arrange them in groups of 4. How many ways can he arrange the action figures? And I don't actually love the way this problem is written. Let's say for now that we're trying to figure out how many different groups of 4 action figures, we can get from 20 total action figures. So the question is, does order matter? Are we picking each action figure for a specific or certain role? And we're not, so that means it's going to be a combination, not a permutation. So I will do 20 probability in CR for combination 4, and I'll get 4, 8, 5, 4, 4, 5. So that one's going to be D. Don't sweat that problem too much. I think, actually, I'm a little unsure about why it was written this way, so let's hold off on this for now. Don't worry about this problem too much, but if you understand this, that's fantastic. 10 says Tracy is getting a new hairstyle. Her options are short, long, medium, curly, straight, color, and the texture is curly or straight, and the color is black, brown, blonde, or red. How many different hairstyles can Tracy make from the choices shown? Okay, so this is the same story as before. We're going to want to draw a slot for each of the options. So length gets its own slot, texture gets its own slot, and color gets its own slot. How many different options for length are there? There are 3. How many different options for texture are there? There are 2. And how many options for color do we have? 4. Okay, so we're going to do 3 times 3 times 4, which I think is 24, maybe. Let's see. Yeah, so 24 different options. So that is answer choice D.